Hey, everybody. So, this is the review for the test. So, if you're not here, then hopefully well, if you weren't here this day, hopefully um, you're watching this and then you'll take the test whenever uh, you come back. So, uh, the day I assigned this, we talked about the first three in class. Of course, if you weren't here then you didn't hear any of that then either. So what I will do here, I need to be off to the side so that I don't block this. Um, so some people already at the very beginning of looking at this were like, well, I don't know what displacement is. Oh my gosh, people. We said the other day, multiple times I've said this, that displacement, right here, this word displacement, is delta x, which is called change in position. All three of those things are exactly the same. They are synonymous. They are the same thing. Displacement is how far you have changed positions, which is what we call delta x. Delta x is the symbol for change in position. Displacement is the term of what change in position means. It means you've been displaced. So this little formula up here, that's how I said you could find it by taking where you ended minus where you started. That's how far your position changed. Okay? Because displacement or change in position only cares about two locations, where you started and where you ended. It's not the same as distance. That's totally different. So, what is the displacement of the first 7 seconds? Well, first of all, you have to know, where were you at the beginning of the time interval and where were you at the end of the time interval? So, where were you at the beginning of the time interval? Well, you were, oh no. Please tell me that this is going to work. Please tell me this is going to work. Oh no. It's not working. My pen is not working. Oh, this is a bad thing here. This is a bad thing. I can't, oh man. Tell me I gotta, oh gosh. Oh boy. Well, this is gonna be tough. This is gonna be tough. Because I can't mark on it except like this. Oh boy. This may not go well. Okay, this may not go well at all. So here's what you need to know. Let me get a different color at least, and let me get a different thickness. Okay. So where are you at time 0? Time 0, you are here at -2 meters. Okay. Where are you at time 7 seconds? Well, here's time 7 seconds. We go all the way up to the line. Head over here. Oh, that's 8 meters, positive 8 meters. So you started this segment, this time interval, at -2 meters position, and then you went all the way up here to positive 8 meters. So how far is that? Well, you went 2 meters just to get to 0, and another 8 meters after that. So what is that total? That's positive 10. Oh gosh, this is not good, folks. This is really not good. Writing on the trackpad, no good. That's positive 10 meters. Okay. Notice, I did not just put 10. It's not 10. Like 10 would not be right. If you put 10, I might give you a half a point for the answer 10 because it's more than just 10. It's positive 10 meters. There has to be a unit of measure. And look what it says. Position is measured in what? Meters. So you need a direction. Up the position time graph means positive direction because that's what kind of slope? Positive slope, which means that's positive velocity, which means you're moving in the positive direction. That's positive displacement. So you need the plus. You need the 10 because that's how many. And you need the meter because that's the unit of measure that describes what the 10 is. You need all of those parts. If you don't put all of those parts for the answer, you will get only part of the points. So please. Now, this thing here, xf minus xi, the final minus the initial, or the end minus the start. I really wish this would work. Maybe it's been long enough. Maybe, is it long enough? Can I write now? No. Oh my gosh. Maybe if I unhook this and then I rehook this, maybe that will help. No. I have no pen. I have no pen action. Okay. So if, let's say I do a text box, maybe that. So this, oh my goodness gracious, please stop giving me 36 font. How about 14? How about 14? And how about we make it, I don't know, the same color as what I'm writing? How about that? So if you take your final position, which is 8 meters, minus where you started, which is what? -2 meters. What is 8 meters minus -2? Oh, look at that. That equals, oops, not plus. That equals what we just said, positive 10 meters. 8 meters minus a -2, minus a -2. That is positive 10. This will never be wrong. Your final minus your initial will never be wrong. I'm going to make that seems awfully big over there. So I hope maybe that makes sense. I don't know. What is the displacement from time 7 seconds to 12 seconds? 7. Where were we at 7 seconds? Well, we just found that. That was here. So now that is not, oh gosh, that is not your final. That was our final position a minute ago. Now it's our initial. That's our xi. That's our x. Our initial position is now positive 8 meters at 7 seconds. Okay, well, where were we at 12 seconds? 12 seconds we were where? Well, all the way down here. All the way down here, and then we look over here. Oh, that's here. So now that's our final. So now we went from, oh boy, we went from a positive 8 meters all the way down to a negative 8 meters in those 5 seconds. So you went from 8 to 0. That's the 0 position at, like, I don't know, what is that, 9.5 seconds? So that's 8, 9, 9.5, 10. Yeah, about 9.5 seconds. And then finally finishing down here at negative 8 meters. So you went 8 and then another 8. That's what? 16 meters. Yes, total 16 meters. Now, what direction was this? Negative. That was the negative direction. Okay, you went from up here all the way. Oh boy, all the way. My trackpad is not. Oh gosh, that's terrible. All the way down to the bottom of the graph at negative 8 meters. That's negative 16 meters total displacement. Now, how does this thing work here? Let's get a text box and find out. Oh my gosh, why? Okay, where were we at the end? Final position, negative 8. Negative 8 meters, final position. Minus, where were we at the start? Initial. We started the interval at positive 8 meters. 8 meters. What's negative 8 minus 8 meters? Oh, look at that. That is negative 16 meters, exactly what we said it was. So I'm telling you, the final minus the initial, okay, the end minus the start will never be wrong. It will always be right. And 3, what is the displacement for the entire time interval? The entire. So, okay, now it's from time 0 all the way to time 12. Well, get rid of this then. Oh boy. Get rid of this. Get rid of this. Get rid of this. Our initial position is now where? Right there. Negative 2 meters. That was where we were at time 0, negative 2. Where were we at the end? 12 seconds, we were where? Oh, -8 meters. Oh, that is our final position. We went from an initial position of -2 meters to a final position of -8 meters. So we went from here to here. Oh boy, that's tough. Now, how far is that? Well, that's 6 meters down to the negative position, in the negative position, I should say. -6 meters, that's what the graph says, is how far we changed from here down to here. Now, displacement doesn't care that you went all the way out to 8 meters and then turned around, came all the way back. All that displacement cares about is that you started at -2 meters, you ended at -8 meters. That's a change of -6 meters. And if we look again at our little deal here, oh, I tell you, driving me nuts. That is, where'd we start? Oh yeah, -2. We started at a -2 meter position, -2 meter position. Where did we end? But minus a -8 meters. What is a -2 minus a -8? No, oh my gosh, I got it backward. Oh my gosh. For a second there, I thought, oh my gosh, what happened? Folks, it's -8 meters. Oh my gosh. Final. I put the initial minus the final. See, and this is where you can make a mistake. I almost did myself. Final, where you end, we ended at -8. Minus, oh, let me get my space there. Minus a -2 meters. What is -8 minus a -2? Well, that's plus a positive, right? That's plus a positive, which is what? -6 meters. Oops, not comma, 6 meters. -6 meters. It is exactly the same as what we just said. This right here will never be wrong. I hope that makes sense. Now, in class, I asked another question. Here's the last question. If you're watching this and you weren't here when we went over this in class, the next question was this. What about interval? Let me put another text box up here. What about the interval between, oh man. This video is going to be way too long. I need to get this done. Between, let's see, what is the change in position? Change in position between 5 and 10 seconds. 5 and 10 seconds. What is the change in position between 5 and 10 seconds? Change in position between 5 and 10 seconds. Well, let me look at the graph. Where were you at 5 seconds? Well, I go over to 5 seconds. I go up here. Boom. Right there. Where is that? Here. What's that? That's 5 meters. That's where I was at the beginning. 5 meters. And I'll slide this sucker up here. So now that's my initial position. That's where I was at the start. Now, where was I at 10 seconds? 10. Right here's 10. Oh, I'm just going to go ahead and say down here, just to make it easier on us. It looks like it's about right here, which is where? Oh, that's a -2 meters. So that means my final, let me get my, there we go. So that means our final position, get rid of that arrow, is at -2. So I went from positive 5 meters position down to -2 meters position. So how much is that? What is the change in position from time 5 seconds to time 10 seconds? I hope you see that it's -7. Do you see that it's -7 meters? Oh boy, can I write this very well? Maybe. It's -7 meters, okay? If you went from 5 down to -2, that's 7 meters total. It's 5 just to get to 0, and another 2 after that. And in what direction is it? Negative. Now, what if you do this mess here? What if you do a little final minus initial, blah, blah, blah? Well, final. What's the final? We said -2. What's -2 meters minus +5 meters? What's -2 minus a +5? Final minus initial. Equals what? 7 meters. Oh, -7 meters. If you have -2 minus another 5, that's -7 meters. So I hope that helps. Maybe I really hope it helps. Moving on, we got to keep going. What is the velocity of the object while it is traveling in a positive direction? That's this section, everybody. That's this section right here. That's from time 0 out to 7 seconds. This whole thing, this whole positive slope section, that is the positive direction velocity. Now, we already found something here. I mean, we already found that at time 7 seconds, it's way up here is where it is. And so if we look at this, if we look at, oh boy, that, and then look at this, like that's our triangle for slope, right? Well, how tall is this? How tall is that right there? Did we already find that? Yes, it's positive 10 meters. That's our delta x. That is our delta x, all right? Well, what's this down here? Well, that's 7 seconds, right? Which is our what? That's our delta t. Now, again, you have to remember that velocity is, oh gosh, writing on this is terrible. Velocity is delta x over delta t. That's something you're going to have to remember. That's part of the test. That's this unit. That's what we found out with the tumble buggies, that's the case. So you have to take positive 10 meters over 7 seconds. Oh man, do I have to? This is where things are taking too long. And that's why this video is going to be terribly long. 7 seconds. I'll pretend that's an S. And what do we get? What is, oh, that looks like a 5. What is that? That is positive 1.343, I think. 43, is that right? 43 meters per second. That doesn't seem right. I guess that is right. Positive 1.4, I'm going on what first period told me. 1.43 positive meters per second, okay? That's what the slope is of that section. Now the next section, what is the velocity of the object while it's traveling in the negative direction? Well, again, negative direction, that whole section. We already found something out, didn't we? We found out that the displacement is negative 16 meters. So it's negative 16 meters, just like we just did, negative 16 meters, oh boy, over how many seconds? That took 5 seconds. And that gives you what? Negative 3.2, oh gosh, 2. I'm trying to hurry, meters per second. Oh my gosh, it's like kindergarten writing. So that's negative 3.2 meters per second. Hopefully that's what you got. Now, you're supposed to sketch a motion map. Well, where does the object start? Behind the 0, because it was at negative 2 meters when the object started. And then what does it do? Well, it goes in the positive direction. For how long? I would say for 7 seconds. Oh my gosh, I have to draw 7 arrows. I would. There's 3, and they should all be the same length, right? Because, again, it's traveling positive 1.43 meters per second the whole time. Where am I at? 5, 6, and 7. Almost hit my velocity time graph. Then what happens? Turns around, goes in a negative direction. Faster. Not just a little faster, more than twice as fast. Do you see that 1.43 and 3.2? That's more than twice as fast as this. It's just the other way. So now I got to, and how many arrows do I get there? 5, because that took 5 seconds. So now I got to do 1, Oh my gosh. 2. This is taking too long. Whoa. 3. Pretend this is straight. 4. Oh my gosh. And the last one, 5. Now notice what happens here. Where does my last arrow end? Further negative out here, further negative than what the first one started. Is that what the graph shows? Yeah. Down here, that's further negative than where we started, which the motion map agrees. Now you're supposed to create a VT graph. Oh my gosh, let me change colors here. VT graph. Well, how do you draw the line on the VT graph? Well, our first velocity was positive 1.43. Where's that? Well, I don't know, somewhere up in here, maybe? Just shy of halfway up, right? How far over do I draw it? 7 seconds. Right there. Horizontal at 1.43 meters per second, positive, across for 7 seconds. How about the next part? Well, now we're negative 3.2 meters per second. That's down below the 3 here. So it's more negative than 3. It's 3.2 negative, but it doesn't start until over here at 7 seconds, and it goes to where? All the way over to 12 seconds, which is the end of the graph there. How about that? That's your VT graph, okay? Now, number 8 says, show how you can find displacement on the VT graph by using area under the curve from 0 to 7 and from 7 to 12. All right, now, everybody, remember, the area under the curve, it is the rectangle between the line and the t-axis. It's between the line and the t-axis. So I would shade this in, right? If you shade this in, that is the area that we're talking about. Now, that's a rectangle. What are the dimensions of that rectangle? How tall is that rectangle? It's 1.43 meters per second tall. It's 1.43 meters per second tall because that's the velocity value. That's how tall the rectangle is. How wide is the rectangle? Looks like 7 seconds. So it's 1.43 tall by 7 seconds wide. What is, I really wish this thing would write. I really wish this thing would write. I can't, oh my gosh. Will this thing, oh my God. No, don't stop sharing. Oh my gosh, I thought we were going to have a problem. So, oh my gosh, it's 1.4, positive 1.43 meters per second. This is taking entirely too long. Oh my gosh, meters per second times the width of the rectangle, which is what? 7 seconds. And so what is that? What is 1.43 meters per second times 7 seconds? That's positive 10 meters. Because seconds cancel seconds. Wait a minute. Isn't that what we already said? Yes, right here. We said the displacement during the first 7 seconds is 10 meters, which is the same thing as the area under the curve. Because area under the curve is displacement. It's the velocity value, the height, times the width, the time value, and that's how far you went, displacement. And you were supposed to do the same thing over here. Now, I'm not going to write it all out because this is taking too long already. And so that shaded in portion, how tall is that rectangle? How tall is it? It's negative 3.2 meters per second. Negative 3.2 meters per second, okay? It is negative 3.2, negative 3.2, oh my gosh, meters per second. Times what? 5 seconds. What's negative 3.2 meters per second times 5 seconds? Negative 16 meters. Negative 16 meters, folks. That is the area under the curve on this segment. It's the height of the rectangle times the width of the rectangle, which is the area under the curve. The same thing we found earlier in number 2. Same thing. That's how area under the curve works. It's just dimensions of a rectangle. Okay, number 9. Describe this object's motion using words. Okay, I'm going to have a big text box here, and here's what I'm going to say. Wow, that's big. Okay, I'm going to say the object starts at a negative 2 meter position. Notice I'm including details here, quantitative details, because I have them. They're on the graph. The object starts at a negative 2 meter position and moves in a positive, oh my gosh, direction with a velocity of positive 1.43 meters per second. I could even say for 7 seconds. You could even add that detail. The object then turns around and it travels, moves, whatever, moves in the negative direction at negative 3.2 meters per second for 5 seconds. The details of what happened are in there, where you started, the direction you're going, and how fast you're going. Those are all in there. That's what you need, and that should be for answer for number 9. Now, number 10, how much distance was traveled during the entire 12-second interval from start to finish? From start to finish. Oh my gosh, is this thing still? Oh my gosh, I really hope this is still recording. If this is not still recording, I am going to be so disappointed. Oh my gosh, I don't know if it stopped recording. Where was I? Oh yeah. Folks, I hope you're thinking right now that it's 26 meters because you went 10 out and then you came 16 back. 10 away from where you started and then 16 back. That's a total of 26 meters. All to end up only 6 meters away from where you started. Okay. You went 10 meters out, 16 meters back, just to end up 6 meters behind where you started. So distance traveled is 26 meters. Displacement is only, what'd I say? Negative 6 meters. So there's that. Now, I got to get me out of the way. I got to change to another page. And again, I don't even know if it's still recording. So this whole thing could be for nothing. And then you're never going to hear this and see this anyway. So what does the VT graph look like here? Well, I would say this. Oh, it's already blue. I need to change it to something else. What kind of slope is that? Positive and constant. What kind of slope is this? 0. That's on the t-axis. What kind of slope is this? Negative and constant. And it's steep, steeper than the first part. So it's going to be down here further, below and further away. That's what the VT graph should look like. What is the written description? I'm just going to say it. The object starts positive position, travels in a positive direction with a constant velocity. The object stops. Then travels in a negative direction with a constant velocity faster than it did before. That's it. Motion map. First dot, positive position. Traveling in the positive direction. So arrows going this way. Just a few of them, I guess. And then what happens? Stops. So dot, dot, dot. Then what? Back the other way, but faster than before. And it gets between where it started and the 0. It's somewhere past where it started, but short of the 0. So that works. Now, the rest of it you don't have to do. If you want to talk to me about it, you can. But that top row is what you were supposed to do. I hope this thing actually recorded the whole thing. Good luck on the test. If you hadn't taken it yet, hopefully this helped explain some things, and I will talk to you later.